find the right tab. Okay. I think you should be seeing my DappNode now.
Yep, see it.
Okay, excellent. So for those who have never seen DappNode, I'm going to show you very quickly what it is. So basically, I am connected now through VPN to my DappNode, which is at my family's house, because I move way too much, I travel way too much. It's at my dad's house, and I am connected through a VPN. So I am tunneling straight into this server. This sits under the desk of under my dad's desk, and I'm tunneling directly to it from wherever I am in the world. When I'm in conference, when I'm here in Turkey, wherever I am. So this is how I connect to my DappNode. And the key feature of DappNode is this Dapp store, right? Like everything here in the Dapp store. You can basically download, you can get a Bitcoin node, you can just click install and boom, and you're installing it. And now we go to packages and we'll see it appear right here, Bitcoin. We can check the logs, voila, it's working. Now I'm going to delete it because I have no use for Bitcoin at this particular time.
Who has used Bitcoin, right?
So at this particular time, I've got no use for it. And yeah, so what's interesting here is that this Dapp store is completely decentralized. And what do I mean by completely decentralized? This is basically a smart contract on the Ethereum network. And I am connecting to an Ethereum node in order to read the smart contract and see, hey, smart contract, what is the content that's available? This smart contract acts as the repository. And the smart contract has a link to an IPFS hash. And this IPFS hash is where you can download these packages, these Docker images. Everything is Docker based. So you download these Docker images that have like this standard form, what we call the DappNode package, and then you basically don't have to configure anything because we know exactly what you're downloading. You're downloading the Docker image that we have, and we know exactly that it's going to fit perfectly with the rest of the DappNode system. And we can configure all the environment variables, all the system variables, and everything as we want. So, but without having to touch anything or connect ourselves. So a DappNode has an Ethereum node in it. So basically you connect, you read this not from an Ethereum node that we provide, which you can as well if you don't want to run your own node. But you're basically locally, you're reading in your own node what's available, and then downloading this content locally as well from your IPFS node. So it's basically you're using two decentralized technologies that you are hosting the nodes in itself to never have to connect to a central server and to download everything here. Now we had to find a balance between UI and user experience and decentralization, right? And before you used to have to wait until your Ethereum node was synced in order to be able to use DappNode. So now we're also providing an endpoint, which you can choose. You can choose to connect to our endpoint or to an endpoint of your choice in order to read this the smart contract. Just to connect to the smart contract and read the repository, and that makes it a lot better. Just in case your node goes out of sync or whatever, you have this fallback. Now, what else? So yeah, let's get into the latest updates that we have done in terms of UI. So you'll see these like stakers on the side. You'll see the stakers menu, and I'm gonna do it in Predator. You basically, when you click here on stakers, you have like this UI that sort of like guides you into preparing all the pieces that you need. Because before we used to like have everything in the Dapp store, and you would need to like, oh, so I need an execution layer. I also need a consensus layer. My keys will go into the Web3 signer. And there's another package which is MEV Boost. And how the heck do I find all these packages here? And now you will not find them because we've moved them all on this stakers UI. And which is like, okay, here's what you gotta do to run an Ethereum validator. 1, choose an execution layer. All right, I'm choosing Nethermind. Then 2, choose a consensus layer and validator. Okay, perfect. I am choosing Nimbus, for example. I'm not going to put Fear recipient address for now. But here's like, okay, you can choose Fear recipient address, whatever it is. You can choose your graffiti, validating for DappNode, and checkpoint sync. So checkpoint sync, I don't have to tell you guys the marvels of checkpoint sync and how fast you can switch between consensus layers. But yeah, you can connect to this node for checkpoint sync, or you can put your own node if you don't trust us or you want to do anything. So there's one of our design principles is to always give optionality to the user, right? The user is self-sovereign. Always they can choose all of the options that they could choose if they were not using DappNode. Finally, let's go for remote signer. This is what will hold the keys, the validator keys. And the reason why we do this is because then you can change consensus client just like that. With checkpoint sync, you're validating again in 2 minutes. And you don't have to worry about deleting the keys here, putting them there. They're always in the Web3 signer, and this helps so much avoid any sort of like slashing risk or any sort of stuff. And then we can choose MEV boosts, and then you can choose the relayers that you wanna choose. I can choose them all. Now,
I have a question about that part.
Of course.
If you go onto the mainnet one, when you choose the MEV boost, you have like the X's. Have you guys thought about like switching the because a red X makes it look like it's bad.
I know, right? Like, yeah, I've gotten this feedback before. Yeah, like it's is it OFAC compliant? Yes, it's compliant, or no, it's not compliant, right? But